When measuring melt temperature, follow safe procedures such as use proper protective personnel equipment, safety shield, heat-resistant gloves, wear long sleeves, and never place the purge on the floor. Any setting on the machine, including barrel temperature, should be based on actual data, not arbitrary recommendations. Since 70 to 90% of the energy required to melt the material is provided by the screw, the barrel temperature should be adjusted for this shear heating. To set the temperature profile to obtain the desired melt temperature, set all of the temperature zones to the desired temperature, run the machine until it's stabilized, measure the actual melt temperature, and adjust the center and rear temperatures. There's a growing movement in the industry to reduce energy consumed by processing equipment. Much of this energy used in injection molding process is with the turning of the screw. Thus, you don't want to waste energy during the screw recovery process. One of the best ways to reduce the energy consumed during screw recovery is to determine the tacking temperature. The optimal temperature is one where the polymer best sticks to the barrel, providing the best conveyance to the transition zone of the screw. Optimal feed zone temperature. This will provide the highest friction between the barrel and the material. If the temperature is too low, pellets stay rigid. If the temperature is too high, polymer melt sticks to the screw. Basically, the process involves the following steps. Start with a low feed temperature and record the recovery time. Slowly increase the feed temperature and look for the lowest recovery time. In the end, set the rear temperature within the optimum recovery time range. This should be documented properly. As mentioned earlier, the heater bands provide only a small percentage of the energy required to melt the polymer. In reality, the primary heater band function is to help regulate and maintain the temperature of the barrel. If you monitor the power consumption or on-off patterns of the heater bands, you can better identify equipment problems. If you're using a simple on-off temperature controller, then you can monitor the percentage of time the controller is on. Many molding machines will provide this percentage. Any significant changes in this value can identify a change in heater band performance. Likewise, a proportional heater band will adjust the power levels to better maintain the barrel temperature setting. This will also show variations when a faulty heater band is encountered. Since machines function differently, you must get to know the regular function of your heater band controllers. Die setters and mechanics often ignore the importance of nozzle sizing. This will result in mold filling and part removal complications. To operate properly, the nozzle diameter must be slightly smaller than the sprue bushing diameter. Larger nozzle bushing diameters make sprue removal much more difficult. Although small diameter nozzles will not interfere with sprue removal, the pressure losses can cause complications in filling, packing, as well as properly losses in the final molded part. Material handling is an often overlooked aspect of good injection molding. Basically, material handling involves storage, transport, mixing, and drying. Your material should be stored in a temperature-controlled, low-humidity area, and it must be properly labeled, covered, and sealed. When transporting material, keep the material covered and sealed. Move the label with container. Open the container only when needed. When possible, mix the material in a continuous method. When the material is mixed ahead of time in batches, any contamination can cause large amounts of material to be scrapped. For this reason, we always prefer mixing methods which perform the mixing as close to the point of use as possible. When a dryer is necessary, inline drying is preferred. Desiccant dryers are the best. Hopper dryers can be helpful. Lastly, along with fine-tuning your process, you should also fine-tune your operation. Poor housekeeping introduces contamination, increases complications, reduces morale, and it causes complacency. In any production facility, the sources of contamination are virtually endless. Contamination not only affects the material and product, but also affects the equipment. Such particles can clog filters, gum up lubricants, and increase the overall dirtiness of the workplace. Good housekeeping decreases time to find things, keeps everything cleaner and orderly, reduces safety risks, and makes everything a lot less frustrating. Employees in a dirty workplace are complacent about material handling, appearance, quality, and safety. In all of my years, I've never visited a workplace that had a good morale yet poor housekeeping.